Hey guys, it's me, Bud, out with another video. For this video, we're going to be talking about special factors. And you may have heard these before if you went through grade 10 right now, or if you heard about it beforehand, like your math teacher told you in 8th or ninth grade about special factors. But for this one, I'm going to be clarifying what you do in case your teacher didn't explain it properly, or you just don't know what you're doing. So for the first one, we're going to be talking about difference of squares. And right now we're going to do our first example by expanding. For this one, it's very similar to the ones where we did binomials. And there should be a bell going off in your head saying, I know what we do FOIL. You are absolutely correct. So it's x times positive 5, negative 5 times x, and negative 5 times 5. So it would look something like this, and then you would have to kind of simplify this down a bit, because as we see right here, we see a 5x and a negative 5x. So we would just do 5x plus negative 5x, or in this case 5x minus 5x, and we would get x squared minus 25. You all know where we got those numbers from? X times x equal x squared, x times positive 5 to make 5x, negative 5 times x to make negative 5x, and negative 5 times positive 5 to give you negative 25. Now that we went through that question, let's go through our second question. Ooh, this looks harder. And some of you might be screaming right now like, what do we do? What do we do? Don't worry, it's the same of what we just did up here. So if we know this, we go 2x times 2x, which will give us 4x squared. 2x times 5 will give us 10x. 5 times negative 5 times 2x, which will give us negative 10x, and negative 5 times 5, which will give us negative 25. And of course, some of you may be saying, well, shouldn't this just be 4x instead of 4x squared? No, we times the 2 together here, and we times the x together. So 2 times 2 equals 4, and x times x equals x squared. That's how you get those numbers. And of course, we have to simplify this down a bit by knocking some numbers down. 10x minus 10x, what we have right here. So it gives us this. Start simplifying it down a bit. Now, you're probably thinking, oh, this question right here is so easy. Get to some hard stuff. Okay, you asked for it. For example 2, we're going to be factoring. Ooh, this looks really hard, doesn't it? And in fact, I can't blame you for thinking that, because from this point of view, you're like, I only got 2 terms right here. What do I do? Well, in fact, first, I'm going to show you the answer. And you may be thinking, I don't get how you got those answers. Well, let's go back to our other example. Do you see a similarity here? Well, I'll first go to this one because this one is more simple. We have the exact same numbers. X squared minus a number, which is the same thing we got here. X squared minus 16. So right now you're thinking, okay, that seems simple enough. So the way how you get this answer is you basically have to put it in 2 ways. You know that x squared, you need x times x. So you put 2 brackets and put xx. And then you know, hey, the way how you get negative 16 is you get a positive 4 and a negative 4. And by the way, it always has to be a perfect square. What are perfect squares? Well, look it up. You'll find something about them. But either way, if you do the FOIL on this question, you realize you get the same answer up here. And you're probably thinking right now, Oh, that's so simple. So just recapping right here, it's basically reverse foiling. You know that we have a negative 16 and we have an x squared. How can we make this number? Oh yeah, well I know x times x gives you x squared, and 4 times negative 4 gives you 16. Remember? Perfect squares. So let's go on to our second example here. Oh, whoops. I don't want to show you that. Alright, so you're looking at this. Seems a bit harder. Well, it's actually not hard at all. It's basically what we do up here. So we know that we have a 4x squared. Well, we know that 2x times 2x makes 4x squared. But what makes negative 49? Well, since since 49 is a perfect square, we know that 7 times 7 equals 49. But since it's negative 7 times 7. So it's bracket 2x plus 7, or negative 7, times 2x minus 7, or plus 7. It doesn't really matter which one you put first. Like, you could actually switch these around and you still get the same answers. Sorry, answers, not plural. Answer. So that's very simple. You're like, okay, give me a harder question. You asked for it. You're probably thinking to yourself, how is this a harder question? Don't I just do the same thing I did up here? I mean, I have a perfect square, and I got the same number up here, so shouldn't it just be, shouldn't it just be 2x plus 6, or minus 6 times 2x plus or minus 6? Well, actually, no. Remember, when you factor, remember we're factoring, you have to look for a common number that basically divides everything. And here we obviously see, oh, we have a 4 and a 36. Oh, 36 can divide by 4 to make 9. So our answer here is 4 bracket x squared. We're just dividing everything by 4, so the 4 goes from here to here. Minus 9. Oh, and 9 is still a perfect square, so we can go even lower than this. Oh, and by the way, you can't, like, divide this by 4, because obviously it has a 9, and 9 is a odd number, and 4 is an even number, so you can't divide this by 4, so you have to do this. But you have a common number that everything can divide by, you basically do this. But we can go lower than this, so we have to go 4 bracket x minus 3 bracket x plus 3, because we have a negative 9. Negative 3 times positive 3 equals 9, and x times x equals 2. Alright, sorry, x2. Bracket. Oh my god. X exponent 2. Oh, that's so hard to say for some reason. Oh gee. This just got way harder. Well, actually, it's not as hard as you think. Remember when we said, A and M for addition and multiplication? Well, that's basically what we do here. And you're probably thinking to yourself, okay, well, A and M means we find a number that can multiply to this, and A, the same numbers have to add to this number. Well, I see a 64. So let's see. 64 divided by 2 makes 32. But 32 plus 2, because the division, equals 34. So that doesn't fit. So 64 divided by 4 equals 16. Oh, wait a minute. That works. So just as a recap, watch the other video where we talked about basically add the A and M, with the A is addition, and the same numbers that equal the multiplication here has to equal the addition. So as we see here, 16 times, negative 16 times negative 4 equals 64, because two negatives equal a positive, and negative 16 minus 4, or plus negative 4, equals negative 20. And you're probably looking at yourself thinking, oh man, but we still have x squares here. Do we have to go even lower? Yes, we do. Since we have perfect squares here, which is 4 and 16, we can still go dramatically lower. Since we know that 16, well, negative 16, the numbers that make that is 4 and negative 4 times together, then we can easily find out that it's x plus 4 times x minus 4, or vice versa. And since we know that the numbers that make negative 4 are 2, it should be x plus 2 times x minus 2. So it should look something like this. So as we see, negative 4 times positive 4, it becomes the negative 16, and negative 2 times 2 makes the negative 4. And obviously the x times x equals x squared. Now, let's do something where we only have two terms here. And as you know, the majority of the ones we have done have always been two terms. So we can easily see that, hey, again, 81, the numbers that make 81 are 9 times 9, but since it's a negative, it's 9 times negative 9. So it should be x squared, because this is x to the exponent 4, so it's x squared. Negative 9 times x squared positive 9. But this can go even lower since they are so perfect squares. So it would just be x minus 3 times x plus 3 to make the first set brackets. And you may be thinking here, shouldn't this one be then x plus 3 times x plus 3? Or x minus 3 times x minus 3? Well, actually, no. Remember the title of this video where it says difference of squares? Well, it wouldn't be very different if the numbers that came out of this equaled the same thing. So it would have to be x minus 3 times x plus 3 times x exponent plus 9, because this is a positive. So it has to stay that way, because the numbers that come out of this have to be different. Like in a negative, you have a negative and a positive 3. But out of this one, it will only be a positive times a positive 3, or negative times a negative 3. And so it basically wouldn't look like this. This is a big no, because you have two numbers that are the same, and the way how I remember this is because it's called difference of squares, which kind of makes me think these two numbers have to be different in, like, one way or another. Like, for instance, if it's a negative number times a positive number. But since these are two positives, it cannot equal that. So just get this out of your head. This is the answer up here. This is no. This is not the answer. So, what do we know from difference of squares? Well, they have to be separated by a subtraction sign, because we want the two numbers that come out of this to be two different numbers. Even though they look the same, one has a negative and one has a positive. We need at minimum two terms, and both terms are perfect squares. And probably looking at yourself minimum. Well, yeah, we did three terms up here, and we have two terms down here, which means we need a minimum of two terms. So both terms have to be perfect squares. Like here, this is a perfect square, and this is a perfect square, and this is a perfect square. Even this is.